Hello everyone, this video shows you how to use the PIE5 for mixed pixel unmixing. The mixed pixel unmixing includes end member number estimation, end member extraction, and abundance inversion. End member number estimation. The high-sum hyperspectral signal identification by millennium error algorithm is a hyperspectral subspace reconstruction algorithm proposed by Jules M. and al. The subspace reconstruction step can obtain the effective band after the dimension reduction of a hyperspectral image, and is an important pre-progression step for the processing algorithm, such as target detection, change detection, classification, and mixed texture pixel classification, which helps to improve the storage and computation complexity of hyperspectral image. Click Mix Pixel Unmixing. End member number estimation. Hessian end member estimation. The Hessian end member number estimation dialog appears. Import the file. Select an import file. Set parameters. Noise tab include Gaussian noise and adaptive noise. Then set the cache size. Click OK to estimate the end member number. End member extraction. The end member spectrum as a reference to spectrum in the process of hyperspectral classification. Feature regression and mixed pixel unmixing has a similar effect to the classification samples in the supervised classification, which directly affects the accuracy of spectral reconstruction and mixed pixel unmixing results. The function of end member extraction uses it to extract pure failures that are end member spectral from hyperspectral images. The group of end member extraction includes vertex component analysis, also orthogonal subspace projection, and end finder. Taking also orthogonal subspace projection as an example to introduce end member extraction, it used the orthogonal subspace projection (OSP) algorithm to extract end member spectra of the hyperspectral image, which consider maximum residual signal of background spectrum and various noise. Click the Mix Pixel Unmixing, End Member Extraction, Orthogonal Subspace Projection. The Orthogonal Subspace Projection dialog appears. Do the following. Select an input file. Set parameters. Number of end members. Enter the number of extract end members as needed, and the default is 6. If you need to combine similar end member spectra, check the option and use SEM algorithm to combine the similar spectra. The default value of same combined threshold is 0.1. Select inverse abundance by needed. This inversion model is an unconstrained linear mixture model. Set the path and file name of output end member spectrum. Click OK to perform end member extraction. Abundance inversion. Use abundance inversion to calculate the proportion of different basic component units in the mixture pixels. The group of abundance inversion includes Latest spectral method simplifies volume and hyperplane distance. The latest squares method is used as an example to introduce the operation abundance inversion. The operation of other functions can be referred to the use manual. Click Mix Pixel and Unmixing. Abundance inversion. Latest squares method. The latest square method dialog appears. Select an input file. Pull down the spectral sources option and select the corresponding spectral file. Select the spectrum from which you want to perform abundance inversion from the spectrum list of the select spectral source file. The selected spectral curve can be viewed via the Draw button. Click the point on the right of spectrum sources that open the corresponding target spectra according to the selected spectrum sources. In the dialog, each row in the table represents a spectrum. Spectrum name displays the name of the target spectrum. The color of spectrum display in the spectrum browsing window, none, means no color by default. The source represents the spectrum sources of target spectra. For example, NV SLL means the spectrum is from the NV standard spectrum file, and ASD file means the spectrum is from the ASD file. Number of bands indicate the number of bands of the spectra. Wavelengths indicate the wavelength range of the unit of spectrum. Status shows whether the wavelength ranges of spectrum sources match the input hyperspectral image. The file indicates which spectral file the spectrum is from. In the table, one or more end-member spectrum can be selected from the input spectra of the latest square method. In addition, for the collected spectra, the following options can be performed. Click Select All to select all open end-member spectra. Click Plot to display the select target spectra in the spectrum browsing window. Click Delete to remove the select end-member spectra. Click the algorithm selection button and select the algorithm that requires abundance inversion. And abundance inversion algorithm can be initiated through the interface, such as clicking the latest squares button after inputting the parameters in the pop-up interface window. You can also switch to other abundance inversion algorithms through algorithm selection instead of having to reopen the interface, enter the parameters. Click OK. The parameter setting of latest square method dialog appears. Select the corresponding constraint in the option of latest square method with different constraint levels. Select the path and the name of the output abundance image. Click OK from abundance inversion.